It's one small step for man, one giant leap for mankind.
My name is Nicole Shoemaker. I am a Research Specialist 5 here at Texas A&M, and I'm helping to lead teams of experts in various interdisciplinary research areas to bring together new concepts, to develop new concepts, to fill the needs of the emerging lunar exploration arena. And one of the new programs that we've recently established is called the Texas A&M Lunar Surface Experiments Program, where we're actually designing payloads to put fundamental science experiments on the moon. So the moon is becoming our new laboratory, and it's a very exciting time. And I don't know if most of the people I come into contact with these days are not fully aware of our efforts to return to the moon and why we're doing that. So we're going to talk about that some more today, what some of the challenges and opportunities are. But first, I'd like to introduce our experts here today, starting with Rob Mueller. Rob Mueller with NASA, not the former FBI director, is a senior technologist and a principal investigator in the Exploration Research and Technology Programs Directorate at NASA's Kennedy Space Center. He's the co-founder of SwampWorks, which is an innovation lab technically called the Granular Mechanics and Regolith Operations Laboratory. And he's the lead of the autonomous robotic systems involved in in-situ resource utilization. And we'll talk a little bit more about what all that means. Rob, do you mind giving us just a couple lines introduction of yourself?
Yeah, thanks, Nicole. Happy to be here. Thanks for inviting me. And what's is true that this is an exciting time because we're going back to the moon. And that hasn't happened in 50 years. And so we are ready. There's a whole new generation just chomping at the bit, ready to go. And we have quite a story to tell today. So I am a co-founder of SwampWorks. I specialize in innovation, and I also specialize in space resources and extracting those space resources and using them to enable space exploration. And so it's a little bit different from Apollo, and I think we'll get into that story as we proceed.
Great, thanks, Rob. And Pete Corrado is here with us as a fellow emeritus of the Bechtel Corporation. Bechtel is one of the largest engineering, construction, massive major program management firms in the world. And Pete received his Bachelor of Science and Master's of Science in Civil Engineering from Bucknell and a doctorate from Duke University. And he majored in civil engineering and minored in mathematics. Pete, would you like to tell us a little bit about yourself and your role in this new arena?
Sure, my pleasure, Nicole. So maybe not a lot of people know about Bechtel. It's a family-owned business. I've worked for 4 Mr. Bechtels in my career. It's been around for over 120 years. Constructed over 25,000 major projects in 160 countries on every continent. And we specialize in building big things and building them first. So we would like to be the contractor of choice for that first big construction project on the moon. I get involved with space business, if you will, a long time ago doing terrestrial launch facilities. Matter of fact, we're currently building the second mobile launcher at Kennedy. But I had the pleasure of being head judge for NASA Centennial Challenge on constructing habitats on Mars using 3D printing. And I'm currently engaged in a brand new NASA Centennial Challenge called Break the Ice Lunar Challenge, focused on mining ice on the moon. There's also another Centennial Challenge NASA is sponsoring called Watts on the Moon, which looks at producing and delivering power on the moon. And I'd encourage everybody to take a look at those. They're easy to find on the web and help you if you want to get involved in the next generation of space engineering. It's an easy way to get involved.
That's great, Pete, and it's truly visionary of the Bechtel Corporation to be taking these steps. And I know there's been a lot of thought around master planning of lunar settlements, and so it's a very it's opening a whole new arena for the upcoming generation. So we'll talk a little bit more about those challenges because I think folks might want to know how to learn more and get involved. So our other panelist is Pat Sewerman. He is the department head of the Construction Science Department here in the College of Architecture at Texas A&M. Pat joined Texas A&M after a long history, retired lieutenant colonel from the U.S. Air Force, 20 years in active duty, and was a professor of civil engineering and construction at the Air Force Academy for many years. He was also the support squadron commander for the 21st Space Wing in Greenland, and has a strong history in expeditionary construction. So Pat, would you like to tell us a little bit more about your...
Yeah, howdy. Thanks, Nicole, and thanks South by Southwest. I'm really excited to be here. Similar to what Rob and Pete said, this is really exciting. Leading the largest construction higher education program in the world with 1,173 students. We're focused on excellence in terrestrial construction primarily, but I know, having done construction in places with area construction cost factors like 2, 2.5, and 3 in Guam, Afghanistan, and Greenland, that we can learn from those projects, and the logistics that help those projects be successful will help inform our practices better here on Earth. And so similarly, I thought, what's the next best step but to go to the most austere, the most expeditionary construction you can do. And I've been excited to learn from lots of experts like we're going to be talking to today, and bring that knowledge back here at A&M, which is one of the homes of the most innovative and cutting edge research that's transforming and impacting our industry. So super excited to be here, and thank you very much.
Thank you, Pat. So there's been talk about ice a little bit, and I think we should start there because there's a reason why we're returning to the moon. It's not just for national pride or for bragging rights this time. This is actually a brand new era that's going to portend a cislunar economy that is based around the water ice on the moon. So let's talk about that a little bit. Rob, would you like to explain why the discovery of water and ice on the moon is such a game changer?
Sure, I'd be happy to explain to you the story behind the water on the moon. When the Apollo missions were happening, we brought back samples from the moon. We had a geologist as an astronaut, Dr. Harrison Schmidt, and other astronauts as well. They did many scientific investigations, and they brought back many samples from the moon in vacuum boxes in order to preserve the pristine nature of these samples. They were analyzed here on Earth, and they were found to be dry as a bone. And that was the common wisdom. There is no water on the moon. And so for many years, that's the assumption that was held in the community, and we proceeded. And recently, in the late 1990s, early 2000s, we had a few missions that went there and looked with neutron spectrometers at the moon. They found evidence of hydrogen. But the reason why the Apollo samples had no water in them is they came from the equatorial regions of the moon, the mare, on the near side of the moon. The hydrogen signatures were found to be at the polar regions. We didn't visit the polar regions, so we had no evidence of water from the Apollo missions. But now we have orbital data indicating the presence of hydrogen. For that reason, NASA sent a mission to the moon, where they actually bombarded the moon, impacted the moon with a spent propulsion stage. And the ejecta, the material ejected from the moon by that impact, was then measured on orbit by instruments. And it was found that in this ejecta, there was a signature, a chemical signature of 5.5% water. And that was the smoking gun. So now we know that we have at least one place at the south pole of the moon from Cabeus crater that has a signature water. And all the other evidence indicates there's probably more water at the South Pole and North Pole of the moon. There's enough water on the moon to launch the space shuttle, a vehicle like the space shuttle, every day for 2,000 years. So there's a lot of water on the moon. The trick is we have to find it, access it, and mine it, and then economically use it.
Great. So water is the main driver of this, and there are a lot of other resources on the moon, and there's also an extremely challenging environment on the moon. And that's why this is not a simple proposition to return and to establish a settlement and a presence there and start mining. Would you care to talk a little about that environment, Pete, in particular from sort of a construction and engineering standpoint? What is it about the lunar environment that makes it so challenging?
Well, difficult environments and mining go together. So to me, I look at this huge resource of water on the moon as creating the equivalent of a gold rush to the moon. And when gold was found in the Yukon, for example, very difficult, very cold, hard to get to place, but the gold brought people there. So the next gold rush to me is to the South Pole of the moon. And it's a harsh environment. So what kind of challenges are we going to see for construction? The number one thing that sticks out is cold, extreme cold. So the water that Rob is talking about is primarily contained in what's called permanently shadowed regions. So the reason it exists is the sun never gets to it. The sun gets to it, it'll warm up, and it will basically vaporize and disappear into space. So it only stays in place as long as it's really cold. Really cold is like 40 degrees absolute. That's colder than liquid nitrogen, for example. So very difficult environment, for humans, but for machines as well. When you get metal parts down that cold, they become almost like glass. So if you have to fracture rock at 40 degrees Kelvin, what tools are you going to do to fracture that rock? The next moving up in challenges is dust. Incredibly dusty environment. You can look at photos from Apollo and it looks like we sent up coal miners, not astronauts. They come back and their suits are just covered in dust. The chimney sweep like dust. Very challenging for not just people, but for equipment, for bearings and motors and everything that moves. Coming up next is probably radiation, not so challenging to certain well-designed equipment, certainly challenging to humans that might have to service or operate that equipment. And then there's, to me, some wild cards, and it's the electrostatic challenge. Moon is highly charged, and I'm a civil engineer, I'm not an electrical, but I know enough, having worked in the power industry my whole life, that an environment where you can't even ground anything, it's impossible to ground to the moon, is a challenge for any of your electrical systems. So those are a few things that we have to overcome. One that's going to be probably the biggest challenge is reduced gravity. Because all the things I mentioned earlier, you can get pretty close to simulating them on the Earth over a long period. Mining's a long duration operation. Aircraft for maybe a minute. How are you going to simulate reduced gravity for a year of operations of a piece of equipment? I don't think you can do it on Earth. You're going to have to find out once you get there.
Mm-hmm.
Those are great points, Pete. I'd like to add to that. It's also a hard vacuum on the moon, so you're going to have some really strange problems like cold welding of metals. If two metal surfaces are exposed to each other, they can actually bond in a hard vacuum, and we've seen that before in space. It's a well-known problem. And you also have something called a moonquake, seismic activity on the moon. That's not unheard of, and that is something we'll have to design for. And we have micrometeorites coming in from space, small meteorites, and these will be a problem. The likelihood of getting impacted or hit by a meteorite is very low, but you still have to design for it. So there's a lot of complexities to operating in that environment, and we're just going to have to do what we call extreme engineering.
I'm wondering then, Pat, in your experience, how some of the military and expeditionary construction and engineering methods are relevant.
It's really about risk mitigation. You're always going to have risk, and in a mission like this, the risk is higher than you've ever had before. And so what you need to do is plan for operational risk mitigation that would take a look at what is the worst thing that could possibly ever happen, which is going to be low probability but high intensity. And you have to look at it on a sliding scale, but you're going to have to look at things more than you've ever done before. And the systems thinking that NASA employs and the types of thinking that Bechtel employs on their EPC or oil and gas support projects that are out in the far reaches of Earth are going to be tested to their limits. And so you're going to need meticulous planning with multiple backup plans and redundancy. So that this is just like military construction projects, but on steroids.
Yeah, Pete mentioned this long life of having to operate in these harsh environments for a very long period of time. I think the key to this risk mitigation is to operate on Earth in analog environments for long periods of time before you ever go to the moon. We can do this in mines on Earth. We can actually improve the technology on Earth and take advantage of these autonomous robotic systems. And at the same time that we're testing them, we can actually be productive here on Earth. So that's where the commercial side comes in. And if we do 5 years of testing in an extreme environment on Earth, then that will give us the data to prepare us to go to the moon. Of course, it's not going to be as harsh as the moon, but that's what we need to do, is just test, test, test.
I agree with you completely, Rob. We do have to get some ground truth information from a commercial side. So I look at the missions so far, and even some of the CLIP stuff. These are science missions. They're go and explore, pick up some rocks, bring them home, look around. But eventually we're going to have to try and work out a technology. So if we want to electrolyze water or somehow liberate hydrogen and oxygen, we need to get to the point where we're setting up a pilot plant, where we're taking the actual equipment that we want to do long-term excavation with and running it on a small scale with the view towards getting to commercial scale operations. So I see that in commercial industry all the time. Something works great in a lab, and then you go out and say, okay, I want to make this where I can make money with it. So I need to take that laboratory operation and scale it up 100 or 1,000 times. So I agree completely. Terrestrial analogs are incredibly important, big part of the scale-up process. We're going to need some pilot plants on the moon also.
So we've established that there's good reason to go back to the moon to mine the water, which is really going to underpin and make more efficient our deeper space exploration. I think a lot of people aren't really aware of the plan that's in place. Apollo was obviously very well known. There's a new program called Artemis, and I'd like to talk a little bit about that and what we should expect to be seeing from NASA in the next 5 to 10 years.
Sure, I can take that. Artemis is a new program that NASA has proposed and has implemented now. We're in the early stages of implementing the Artemis program. It starts with a series of robotic missions that will land on the moon once or twice a year to investigate the environment, the properties of the soil, geotechnical properties, other environmental issues. Pete mentioned the electrical properties, the plasma environment. So we really have more to learn about the moon, and also to scout the location where we might want to build a future moon base. Once we have that data from the robotic missions, then we're going to land the next man and the first woman on the moon, which is currently scheduled for 2024. And we'll see if that schedule holds, but that's the goal right now. And after that, we'll be landing one mission per year with humans on the moon in order to set up a sustainable presence for the future. Sometimes they call the Apollo missions the flag and footprints mission. You go down, put a footprint on the moon, plant a flag, and go home. This is different. This time, we're looking at the use of resources to have a sustainable presence on the moon. That's what the Artemis program is all about. But really, Artemis is also a proving ground for Mars. Mars has evidence of past life. And so it's an exciting planet because it may have once have had life, and it was also Earth-like in its early existence. So what happened to Mars? If we understand what happened to Mars, we can understand the solar system better. We can understand our home planet better, planet Earth. And planet Earth is a precious place. If we understand the solar system, then we can understand our place in the solar system, and then we can protect our home planet. So there's a big picture here that we have to keep in mind. And the moon is just a small piece of that big picture.
So it seems there's another significant difference between the Artemis program and the Apollo program in the way that it is intimately involved and tied to the commercial sector, the private industry, emerging space sector. Could you speak a little bit about that? And then I'd like to hear from Pete too, as far as the Bechtel Corporation vision.
So Apollo was arguably the pinnacle of human achievement ever, arguably. It was also very expensive, and it required a driving force, which was the Cold War, and really a survival instinct is what drove us to go to the moon. It was part of the Cold War, and it was very expensive. This time we're going to do it differently. We're going to have international partnerships. We're going to have commercial partnerships, and this will let us do it for a reasonable cost with arguably a return on investment, a large return on investment. But we can't do it as NASA alone. NASA is a government agency. The role of the government is to facilitate industry. And so that's what we're doing. We're setting up the framework, the infrastructure, and all the processes, the legal framework, communications, launch sites. This is all necessary. And then private industry can come in and do what they know how to do, which is make some money, create an economically efficient system. And so that's what we're looking for private industry to do. And we call that a public-private partnership. And then Pete can explain to you how companies like Bechtel propose to help us. But this is definitely not NASA going it alone. This is going to be a commercial, public-private partnership, and probably with also international aspects to it as well.
Yeah, so coming from the private sector, simply stated, it's all about return on investment. The private companies, they're not in business to explore. They're not out there for glory. Simply, it's the American dream. We're out to make money. So right now, in commercial space, it's all about people that fly, and they are making money. So when you look at the SpaceX's, the Blue Origins, and others, they have contracts. They have people who pay them for their service. When we get to the surface development, when we want to exploit this gold rush for water on the moon, who's going to pay for those services? So that's a challenge for the international community. There are companies out there ready and willing with the skills and the ability to go do this. I was actually on the phone with a major mining corporation just this morning, and we were all just buzzing about this gold rush on the moon. But who's going to pay for it is one of the big challenges we have. Once that's solved, I think a lot of things will just fall into place. So I've heard people talk about the price they're willing to pay for liquid hydrogen and liquid oxygen available in the cislunar area, whether it's low Earth orbit, on the surface, to something that doesn't have to be lifted off of Earth. There's a price for that out there. And getting a guaranteed contract to deliver at a fixed price will go a long way towards commercial development on the moon. Certainly some legal aspects that need to be discussed. And Rob, maybe you can tell us a little bit about Artemis Accord and what you think that might have in the way of influencing commercial development.
Well, yes, that's a good point. The 1967 Outer Space Treaty from the United Nations, that's what we go by today. But it's a little fuzzy. It doesn't tell you exactly what you can do in space. It does tell you that you can't own the moon. You can't claim sovereignty on the moon. But the use of resources, that is not clear under the 1967 Outer Space Treaty. It's open for interpretation. As a result, the US government, they have interpreted the Outer Space Treaty in a different light than some people have. The US interpretation is that we will not claim the land or claim sovereignty, but we do have the right to use resources, and commercial industry has the right to use the resources. And this is law in the United States. So any entity that launches from the United States does have the right to use the resources on the moon, but you cannot claim the land. And that's really the essence of it. Now, this is not a hard law, hard international law, and it hasn't been ratified by any nations in the United Nations. So we're operating under what we call soft law. And soft law is where you make a suggestion. And that's where NASA and the US government has published the Artemis Accords. And this is a series of guidelines, suggested guidelines. And in the legal world, if enough people embrace those guidelines, adopt those guidelines, and sign up to operate under those guidelines, over time, it becomes de facto law. So it's kind of like trying it out to see if it works, and if it works, it becomes law. So NASA has published these Artemis Accords, which are guidelines on how to operate on the moon, and some of them are very, very good for the international community. For example, rescue capability. If another nation gets into trouble, the Artemis Accords advocate rescue capability and common interfaces. So these are beneficial guidelines. And so we put those out there. Several nations have already signed up to them. They're still being examined by other nations, but hopefully everybody will get on board and we'll have a common legal framework under which to operate. But I'd like to give you an analogy. Alaska was purchased in the 1800s, and it was called Seward's Folly, because the gentleman that pushed this was a senator, I believe, and his name was Seward. And for the first 50 years after Alaska was purchased by the United States, it was chaos. It was a very rich place in terms of mineral wealth, but nothing happened. It was only until about 50 years later, when the laws were put in place, the legal framework on how to have jurisdiction, how to have mining rights, that Alaska started becoming profitable. And so this is similar to the moon. If we don't have a legal framework where we allow commercial entities and international partners to operate under a legal framework, there will be chaos and it will not be possible to do business on the moon. So this is another role for the US government, and I think that's moving along very nicely with the Artemis Accords.
And this is becoming relevant sooner than we think. than most people might realize, because we're actually going to be returning to the moon later this year with commercial private landers. Can we talk a little bit about that, the Commercial Lunar Payload Services Program?
Well, this is the first example of something that's already working. In the early 2000s, we put into place in the mid 2000s, about 2005, 2006, NASA conducted an experiment. It's called the COTS program, Commercial Orbital Transportation Systems. And the idea was that we let private industry deliver cargo to the International Space Station. Remember, when Space Shuttle was retired and we didn't have a logistics capability anymore, and we were paying the Russians to fly our astronauts. So the COTS program was designed to try out this new commercial model where we contract out and then we buy it as a service. And the COTS program worked. It was very successful. It's successful today. Arguably, SpaceX wouldn't exist today if the COTS program hadn't funded them at the time that they did. So this is a success story. To build on that success story, we have the CLIPS program, Commercial Lunar Payload Services. It's similar to the COTS program where they deliver cargo to the International Space Station. And now we're asking private industry to deliver science experiments to the moon to get ready for the Artemis program. And we already have 4 vendors on board, and this is we have a whole list of vendors who are competing for these contracts. It's going to be very exciting. We'll have at least 1 mission per year to the moon, and it's going to inspire the next generation. If you're in high school today and you see these landers landing every year, that's going to be inspiring. And I think the public will wake up and see that the moon is a very exciting place and a huge opportunity for us.
It is very exciting. So as we are looking at the lunar settlement activities really as a portal and a stepping stone to Mars and deep space, can you help us understand, and I'd like to hear both Pete and Rob's perspectives on the capabilities, development, and experiences that we will gain on the moon and how they will be relevant and help us as we continue on to Mars?
Let me kind of kick this off. I see 2 things that need development. Technology in extreme extraterrestrial environments. And of course, the Mars surface is quite a bit different than the lunar surface. But there are enough similarities, such as reduced gravity, extreme radiation, micrometeorites are there, dust, that there'll be a lot of crossover. There'll be some unique differences, particularly the latency of a command signal from the Earth to a piece of equipment on the moon, very short. It's like doing teleoperations of a piece of mining equipment in South America from, say, Caterpillar's home office in Peoria, Illinois. But if you're trying to teleoperate a piece of construction equipment on Mars, your latency is measured in tens of minutes, maybe 20 minutes, 30 minutes, depends on the relative position of the 2 planets. So you're not going to be able to use the same command of your construction equipment. One will need more artificial intelligence, and the other one will be able to lean on a terrestrial operator. So there's technology overlap and technology challenges. Rob's discussion of the Artemis Accords is really spot on for both locations, Moon and Mars. How are we going to, maybe it's not laws, but there's got to be a way to effectively develop these 2 extraterrestrial bodies. So for example, we're talking mining here. It's one of the fundamental engineering operations there is. It's also one of the dirtiest, nastiest, most invasive things you can do to a planet. If you've ever gone to a big mine, you don't want to live next door to it. There's a lot of people say, well, you need to fill them in when you're done, which can be a very expensive proposition. So when you go to the moon and you start mining water, who's the quote environmental advocate for the moon? Who's going to say this is as far as you can develop it? That's a real question that's going to come up, and we need an answer, and it's going to be a bigger question on Mars. So we're going to learn a lot, both technically and commercially, when we go to the moon.
Yeah, I agree with that. And I think it can be done. Of course, we have to do it responsibly. And that's also a role of the US government, is to make sure that things are under control and under a responsible jurisdiction. And we can do that. I think we have the experience on Earth to successfully run a mining or construction operation safely and responsibly. So I think we can get there. But I want to touch on something Pete just said. Is I think the biggest opportunity commercially right now is robotics and autonomy. If we take the Venn diagram of operating on the moon and operating on Earth in construction and mining, the intersection point that is the most obvious to me is the robotics and autonomy. The construction industry hasn't changed in about 100 years, and the mining industry hasn't changed in about 200 years. The miners will argue with me on that, but the equipment has gotten better and they're going deeper, but now they're going so deep. I was in a mine in Sudbury, Canada, a nickel mine. It's very interesting because they're actually mining an asteroid in Sudbury, because the nickel in the ground in Sudbury came from an asteroid impact. So we are already asteroid mining today here on Earth in Canada. And the deeper we went, the hotter it got. And it got to the point where I said, well, how much hotter is this going to get? And they said, good question, because we're reaching the limits in some of these mines where we can't pump enough cold air into the mine to keep things going the deeper we get. So sooner or later, if these mines get too deep, then we're going to have to use robots. And so that is coming. And so we need the same technologies in space, and we can have a dual use technology where we operate robotically in mines and construction sites here on Earth, and that will give us the experience and the testing we need to go operate in space.
I think
Great point about robotics and use of teleoperations, Rob. And it is affecting mining on the planet here because of labor shortages. So a large facility, say in Western Australia, where we've just finished building a big liquefied natural gas plant, truck drivers are making close to $250,000 a year just to drive a truck because you can't get them. So people want to replace them with, self-driving trucks. And Pat, I'm sure you have a lot of interest in not putting people at risk in your expeditionary construction as well.
Definitely. I mean, everything you talked about there you have to plan for them. Just like the environmental impact analysis process here on Earth, that's the best way to be an environmental steward, is to plan for success. And that's having been at a previously Russian base, which is Bagram in Afghanistan. When we built up Camp Bastion in the Helmand province, we started with master planning. And then we started with the street grid system, and then we did a more sustainable infill of the types of requirements that we needed. So that Port Authority, that planning concept is going to be needed on the macro level for sure. And then down to the next man and the first woman who are going to be part of that mission, there's no doubt that just like in mining, there are going to be things that are dull, dirty, and dangerous. And that's partly what we look at in the research in our program in construction science, at how we can minimize those dull, dirty, and dangerous missions and mechanize, automate those capabilities. So it's definitely an emerging area that's going to revolutionize construction.
It's a concept that's kind of near to my heart, and I wanted to get Rob's opinion on it. Rob keeps saying the United States is going to help lead this. So these are truly international operations, I believe. Artemis must have international partners. And when we go to develop, say, a permanent base that supports a mining venture, we need, I would say, a multinational view of how to control and develop that. Could I hear from you on that, Rob?
I think that's a possibility. Goes into policy, which I'm not really qualified to talk about policy. We implement policy, we don't make policy at NASA. So it depends on what the US government wants NASA to do. I think US leadership is necessary, but if you look at the Artemis program, it is international, and we have the European Space Agency providing parts that are in the critical path. But it will depend on what each nation brings to the table and what the mutual benefits are to each nation and what the policy implications are. So I'm not really going to comment on that because NASA's job is to implement policy and not to make policy.
Great. So in the last few minutes that we have here, I'd like to give you each a chance to share with the audience who may be school age or folks with school age kids, middle school, high school, college, or even younger. And what advice would you give them as we enter this new space age with all of the technological development, international political considerations that we're going to need to figure out to get there?
Well, I can go first. For me, it's simple. Think big. Just think big. Don't limit yourself. Sometimes people ask Elon Musk why he does what he's doing, and other people like Jeff Bezos, and they'll ask astronauts why they're doing it. And you know, why are we on this planet? We have to think big. We have to have a future, and that's why we're doing it, is to have a future. And if you're in high school today, you have the most to gain from that future. So really, when I was in high school, I was a little scared of getting a job. I thought it would be boring. And then I found NASA and said, hey, this isn't so bad. So if you're in high school and you want an exciting future, you know, space is very exciting, and it's bringing the human race forward. And to me, that's what it's all about. Think big, advance the human race.
Rob, you know, it's wide open opportunities. It's, you know, the Earth is limited. Space is unlimited. You know, maybe you're not able to engage in what's going to happen on the moon in the next 4 or 5 decades. Mars is next. The moons of Jupiter are next after that. The asteroid belt, it never ends. It's bigger than big, Rob. It's a huge open opportunity for all areas of not just technology, but we've talked about legal and social, economic issues that are open there. So it's not just STEM education, which is a huge part of it, but it's every aspect of civilization, and it's wide open.
That's what I would say. Knowledge is not an assembly line. You can't specialize in the one thing that's in your comfort zone. You need to be focused like the Renaissance period and know everything. You can't just know chemistry and be successful in space. You can't just know physics. You need to know everything. We used to have a saying at the Air Force Academy, we need to be both Athens and Sparta. You need to be creative and wily and use your muscle when needed, but you need to be refined and informed and thoughtful. So that's one of the things that I think that the people who are, that's why the public-private partnerships are so smart, because it's leveraging everyone's strengths. And that's the future of collaboration that's going to be successful. And I feel why America has always led this race and will lead the race internationally, because we're the best at making high-performing teams collaborate.
Thanks, Pat, and thanks very much, Rob and Pete, for all of the very thoughtful and interesting commentary. And I fully agree. It's a tremendous opportunity for us at an academic institution like Texas A&M to start to foster those interdisciplinary collaborations and to team with industry, to team with NASA. So on that line of thinking, Pete, you mentioned a little bit about the Centennial challenges that you're involved in. Could you explain a little bit about those? Because those are live and happening.
So Centennial Challenge is just a great program by NASA. The amount of money they put out there to stimulate creative thought. And Rob pointed out that the use of challenges to stimulate technology goes way back, actually back to as far as Napoleon at least, where he put out a challenge to have sustainable food for his armies and basically developed canned food. And has gone forward through the Ortigue Challenge, which got Charles Lindbergh to fly across the Atlantic and out to X Prizes. So the two challenges that deal with the moon specifically that are going on right now are Break the Ice Lunar Challenge, which is a mining challenge. And you can find it, just Google Break the Ice Lunar Challenge. And the other is WATTS, W-A-T-T-S, like the electric power on the moon. They have clever names, and it's focused with developing and delivering power on the moon. So when you look at extraterrestrial effort, power is the key. If you have enough power, you can do anything. You can melt rocks, you can laser stuff, you can grow plants, you can create oxygen. So Watts on the Moon's a big one. And these challenges are open to anybody. Your weekend inventor who goes out in the garage and tries to build a better mousetrap. The big, world-class research universities like Texas A&M, startup companies in Silicon Valley, major corporations, high school kids. Anybody can enter these challenges. There's no entry fee, and the one we're working on right now doesn't even require any hardware for Break the Ice Lunar Challenge Phase 1. $500,000 in prize money's available. So I'd encourage anybody watching this to take a look at them, even if you don't enter. There's some really fascinating information describing the challenges to technology the way NASA sees them.
That's great. And yes, we are endeavoring to enter the challenge, actually here with a group from our aerospace team together with a company partnership. So I want to thank all of you very much for the time to come and speak to us about this. And we are very excited here at Texas A&M to help further this effort to foster the interdisciplinary approach that is required, not only within the disciplines, but with NASA, with private industry, with international participation, and do what we can to really foster the development of this new space age and our expansion off of this planet. So thanks very much. I really hope we were able to continue the discussion, and really enjoyed speaking with you all today.
Thank you. I'll see you on the moon.
See you on the moon.
Thanks, Nicole.
Thank you.